All right, everybody, we are back. Next up is MicheleTitolo. She's been making iOS apps for over 5 years. She shipped over a dozen apps to the Apple App Store and designed and implemented APIs for a number of them. She enjoys debugging, refactoring, and finding elegant solutions to difficult problems. And outside of work, she's the CTO of Women Who Code and an avid Doctor Who fan. So we'll go ahead and turn it over to Michele. And I'm just excited to see this talk.
There we go. I am no longer muted. Can everyone hear me? Cool. So I need to go back and doing this without notes. So it'll be fun, I swear. So thanks for the introduction, Charles. As you said, I'm Michele, and today I'm going to give out APIs, the good, the bad, the ugly. I've built a lot of apps, and every app that I've shipped to the App Store has had one thing in common, and that's they all talk to a web service. So I've used a lot of different APIs. I've helped design a lot of APIs, and I'm going to kind of share the best and the worst of what I've seen. So we're going to cover, oh, my camera just is blinking. There we go. Okay. Want to make sure you can all still see me, even though you're looking at the slides. So what we're going to cover today is a bunch of different aspects of APIs, and then just kind of go through what's good about them and then what's bad or potentially ugly. So first one, API documentation. It's good when it exists. The best documentation that I've found is when it is interactive, something like IO docs, because as you know, as a client engineer, as I'm going through and using this API, I need to see the edge cases. I need to see what fields are nullable. Sometimes it doesn't actually say that in the documentation. I need to, you know, try different conditions to see if a problem is reproducible or not, or if it's just something that I'm doing. So these kinds of documentation, like, is the best documentation, just because it makes me not bug API engineers, which they really like too. What's bad? When you have documentation that isn't updated frequently, this happens a lot when you're dealing with agile or scrum situations where like every week something new is coming out, but the documentation part of that task isn't completed with the completion of the tasks. So then, you know, something gets deployed and then all of a sudden, you know, the app stops working or starts crashing, which is the worst thing to happen. And it's all because it's like, oh, this thing, we changed it from a Boolean to a number. And it's like, oh, okay. Or we changed the date stamp and all sorts of different things. The worst things is obviously if you have no documentation. It's really hard to build against an API when the only thing you have is a list of endpoints, especially when you're dealing with complicated things, post parameters, headers, and every single app I've built has dealt with paging in a different way. So you always have to go back and check the documentation multiple times while you're developing. So without it, it's really hard to work in a fast-paced environment. And a lot of people like to think that, you know, just look at the code, it's self-documenting and all of these things, but especially in a lot of the service-oriented systems that we work in now, there's not really like one API file that you look at. You have to, in Rails, for instance, it's like, oh, well, it's not in the API controller, so you have to go into like the user's controller, and then there's like a helper method that it calls out to, and then all of these things. And, you know, code really isn't self-documenting unless you're in the code base every day, and then it's even kind of wishy-washy in my mind. So having really explicit documentation that is available to people who don't have to download your code base is a huge, huge, incredible step forward. So document your code. URL formats. What can be good about them? Consistency. You would be surprised as to how inconsistent I've had to make some URLs in the past. This is a pseudo example from a product I did a couple of years ago, where you have a user, and then you have a user ID, you have a product, you have a product ID, you have a movie, ID, and then you want to get the times for the movie. So that's pretty consistent, where every time you have a thing, you have your resource, it's pretty restful. What's not so great is when their things are not consistent. So you have things like, users ID, so you get the user with that ID, that's great. But then you have these other two things that take other IDs, and those aren't reviewer time IDs. I've had to do this in a couple places, and it just gets really confusing because you're always talking about an ID, but you always need to talk about, like, is it the review ID? Is it the movie ID? What happens if you pass a movie ID and it expects the review ID, and then just it kind of gets all mixed up, and it's really, really hard to communicate. Then the ugly is when you do really silly things like this, when you have to, like, not using the proper HTTP verbs or having destructive gets. I've done this before, and it is made me very, very, very sad. Just because, there's a reason that we have all of these markup semantics, and we need to use them, because something like this, first of all, it's just, kind of silly and annoying, and please don't do it. But it also leads to a lot of problems, because if you're trying to test this out in a browser, for instance, and you forget that if you just go to this one URL that sometimes has, like remove or delete or something in it. But if not, like, that's just going to delete the thing you were trying to look at anyway, and then you have a whole mess of problems. So please don't do that. You will have most client-side developers or people consuming your API just scratching their heads or running away screaming. Payloads. These are particularly important to me because I don't know, they're really important because I need data. So good things about payloads are when they actually return you all the data that you need. I remember talking with a friend who worked at, I think it was Yammer, a couple of years ago, and one of the things that they had to do there was to load their home feed, they had to make something like 19 API requests. And that's not even loading like images or, assets. That was literally, they needed to get, 19 separate blobs of JSON to construct that feed. And that's just a really bad experience for the end user. If you're doing, I'm a big proponent of really dumb clients. So if there's any sort of processing or taking of like 3 different things and putting them together in a list in a specific order, it's a lot easier to put that on the server than have the client do 3 separate requests, any one of which can fail for many number of reasons, and then have the client side replicate that behavior. There are other reasons, because of the way that mobile apps are particularly distributed, that's problematic. But in terms of API design, it just means that, there's a lot more work that the client has to do, which means that the end result to the user is going to be way, way, way slower, because 3 requests come back, process the data, display the data, versus 1 request, come back, display data. So ideally, API payloads have all the data that you need. And while REST is really great for this, there's going to be sometimes, feeds are a great example, where you need a lot more data. So sometimes it ends up kind of breaking the REST paradigm. But what I've found is that that's okay, because it's a better user experience. And it's not exactly breaking. You just make a new endpoint that just takes the data from 3 separate things. So it's not like you're changing your other endpoints. You're just adding a new one that does all of the work for you, so that you don't have to go through and do all this extra work client side. So bad. So uh, I did one app for a e-commerce company. There were multiple ways to get a product block back that had all the product information in it. And this is an example. I actually went through all of the endpoints that we get products and mapped out which one mapped to which, because if you're getting a list of products from the products endpoint, the product ID would just be ID. If you were getting a specific product ID, so product/product/ID, the ID field would be product ID, capitalized. And then if you were in the cart, which will return you a product payload as a sub-object in the cart object so that you could, display the price and the size and all of those things, it would be product_ID. Now the code for this was pretty terrible because in order to properly parse the JSON into our models, we had to check if it had an ID field and then a product ID field and then a product_ID field, which is just really, really messy. And this is something that happened organically over time. New endpoints were added. There was not a templating system in place, which could really help in this situation. I mean, this was back, like, they were running Rails 2, I think, so really, really old. But still, this is like a client-side engineer's worst nightmare because, instead of just having a 1-to-1 ratio, I now have to go through and map multiple things, and then you kind of start wondering what else is inconsistent about this API. And let me tell you, there were a lot of inconsistencies in this API. So yes, this actually happened. And another thing that this kind of pattern, not really, I guess anti-pattern predicts is the fact that things are going to be changing out from underneath you. So there is a certain kind of contract you establish between a client-side engineer or the API consumer, I'll call it API consumer, and the API developer, and that, you assume certain things about the APIs that you're using. You're assuming that if you call a certain URL, a certain set of parameters, you'll get a certain chunk of data back. One of those things, especially on the mobile side, is if you're getting an image URL, it will have HTTP or HTTPS, or it will be a full URL that you can just, throw into something that will automatically load, no processing, no whatsoever. And sorry, I don't have notes, so not quite sure what's coming next. And so, yeah, this was a problem. I had one same e-commerce client. One time they did a release, and for one API call, for reasons on the website, they removed the HTTP from all of the images, and it was like the product detail. So it was like kind of a really important API call. And that just broke the app because, we were just taking the image URL that they were giving us and, just loading it automatically and not doing any processing on it. And that could be really, really bad. I mean, there are definitely more security and privacy minded reasons why that's bad, but in our case, it just, the VP was trying to demo the product to like the CEO, and then none of the images were loading, so it was just kind of a fire that we had to put out. So they had to rollback the deploy. Dates are also probably my biggest pet peeve as someone who consumes APIs all the time, because there's so many different formats, and I've definitely seen the problems where a new cluster of servers will be rolled up, but for some reason, the date format that those are sending different ones. I don't exactly know why, because you think that all gets handled at the application level, but occasionally they'll send things like extra time zone information or microseconds or milliseconds, which, the dates are sent over the wire as strings because JSON doesn't have any expression of date. So we're doing string parsing. And string parsing, obviously, when you change the format of the string, will break. So also really good to be consistent and to just be aware of changes as they happen, because they really should, payloads really should be tied to a specific version of the API, which I will get to a little later. So API consumers expect certain things, not change. And that's not even the worst part, unfortunately for us. So I've seen some really fun things. I've gotten JSON payloads that just contain HTML where it was literally a JSON payload with one key and one value, and the value was a string of HTML. So don't do that. Anytime you start getting meta about your APIs, that probably means you're being too clever. I haven't seen this, but someone on Twitter did last year an XML response containing one in which returns a real XML document as an escape string. And that's just being clever, just not being a good API citizen. You want to be clear and you want to be concise, and having JSON and JSON, or HTML and JSON, and XML and XML, that's just really hard for people to even mentally parse sometimes. And this also leads to a lot of instability. I don't know if any of you have tried to actually write an HTML parser. I don't recommend it. But anytime you're dealing with a data format that is going to be continually changing, you're just going to be chasing after bug, chasing after bug, chasing after bug, because everything's unstable. And we really, really want stable APIs. When, I understand during development that things are going to be a little shaky. You're trying this new database ORM or something and not sure what it'll be like. But at the end of the day, payloads really need to be stable. Otherwise, things are just going to break. And no one likes it when things break. And it's even worse when it's a mobile app, especially on Apple's platform, because the quickest time that you'll be able to get a fix out is usually about 3 days. Unlike web servers, we have to think about, okay, what is the most critical bug we can ship with that will, not be the worst thing in the world for 3 days. Okay, now, authentication. It's a big topic. It seems like there's a new security thing that happens like every week because of authentication. Good authentication. I'm a big fan of HTTP basic, using SSL, of course, when SSL is secure. And as of iOS 9, Apple will actually start requiring SSL on pretty much every call out to the network that you make in your application. So SSL is really important. And obviously, you need to have SSL be secure. OAuth is a token-based system that a lot of companies implement, for better or for worse. It is so it's pretty widely adopted. People don't generally need a ton of information. Once they've kind of learned it once, they can use it a bunch of places. So those are kind of the two big competing standards for authentication for user authentication, not application authentication. So bad, OAuth again. There've been a lot of really interesting things happening in the realm of authentication on mobile devices recently. Android's not really a problem because it has this account manager that could be really great. But Apple is really, 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 really strict about some things. And turns out the most secure way to do OAuth on an Apple device is to actually go into mobile Safari and then come back. But Apple rejects apps that does that, so you can't do that. So it's not the best. It still requires a web presence somewhere, usually for users to enter their username and password. That's getting better in apps just because you can now do some cool stuff. But it's still kind of a pain because you still have to have a bunch of code and some third-party applications trying to access your server, and they have to throw up a window to enter in their credentials, and it's not the best. It's much better as a web-only experience, but for like mobile applications, it's a little funky. Um, but mobile developers really not a huge fan of OAuth just because it tends to be a bit of a pain for us. This was I asked what are some of the people's pain points, and I just thought this was hilarious. And that's not even the worst, unfortunately. So a lot of developers like to think that they're really awesome and they know the best way to do things. So they want to be Bob the Builder and go out and build their own, which is not the greatest. So there's a reason that open standards exists, even if it's something simple like HTTP Basic or OAuth, or if it's a single-use API that for like websites, something that's token-based, obviously. But what it really comes down to is the fact that using an open standard saves everyone a lot of time because then you're not reinventing the wheel over and over and over again. And I've seen some really interesting systems out there requiring token handoffs and several different kinds of encryption, which is also a problem to deal with because writing code for encryption is, fraught with peril. So don't build your own, please. Authorization. And by this, I mean, so authentication is for users. So if I have an account on your site, I can authenticate as a user to access the data. Authorization, which should be separate and should always be separate. There should always be a layer for just the application level of accessing information. There are so many reasons why this is important and why just, not closing off your API to people is going to go terribly horribly wrong. So good things about authorization is that an app requests permissions. When I was at Reddit, we actually had apps, even the in-house apps would request a set of permissions to go with the OAuth token they were requesting, and they would request that with a custom endpoint that we had to get a specific token that was device only. Or they have a device only token flow, which then use that token to get the OAuth token. So it's like 2 tokens away from any sort of secret. And app request permissions, which is really great because then you have built-in, user level permissions on what the app is doing, what the app is accessing. And obviously for third parties, this is extremely important because if a user doesn't want to give someone access to their contacts or, their private messages or something, that they can control that, or they can at least see what each app is doing versus just being like, I don't know how many of us would like use Google login. That's actually a really great example. Every time you do a login with Google, it shows you a list of permissions that the application is requesting, and that is authorizing as well as authenticating. Bad is you have one API key. This is the most common way to do it where, you log into, I don't know, not Twitter because Twitter's a bad example, but you log into some website, you go to the developer section, you request an API token, and then that's it. And that's the only token you ever get. That's a good first step, but those are very easy to lose. They're very easy to copy. And they're, one-time use for all of the things. So, it's a lot harder to do things like session tracking, rate limiting, and all of that stuff on the back end when all you have to work with is one key that like every person who downloaded this app is now using to access. So the ugly is there is nothing, which is just kind of opening yourself up to hurt because there's unfortunately a lot of bad people in the world who just like DDoSing your site, and having 2 steps in order to get for someone to get especially access to account level information is not only more secure, but it makes them feel a little bit better about using your product and giving you their data because they know that anyone else who wants that data has to ask for it. This is also good because we have security vulnerabilities that happen. So if you're able to track, like, for example, if part of the process is you have to send a specific header that has, like, I don't know, the version number of the operating system that they're running, you'd be able to check for vulnerabilities in certain things before you send back any sensitive data, which is a huge step forward from what most mobile developers are doing right now and what most API developers are doing right now. But it's something that can be done, and I think it's something that should be done a lot more. Oh, and then we also have the fun thing about proxying. So people think that the phones that they use when they're like on their phone, on their bank application, that they're really secure because no one can, get in between their phone and the bank server. But that's not true. Obviously, cellular networks are a lot more secure. They're still open to some vulnerabilities, but it's mostly the Wi-Fi that we all have to worry about because people just leave their Wi-Fi on their phone. Their phone just connects to Wi-Fi all the time. So Charles is a really useful tool that I know I use a lot when I'm debugging APIs against my device and my computer to just kind of see what's going on under the hood and to get all of the headers and whatnot back in a nicer format than I get when I'm actually in my editor. But it's really easy to set up a proxy is basically what I'm saying. So you can't always count on that being secure. And there's also, like, people do this. They actually set up proxies on their iPhone. So you can't actually trust sometimes who the other person is on the end of the line. So having no sort of application level authorization is just not secure. Error handling, because bad stuff happens. Good error handling uses HTTP error codes.
Can I stop you for a minute, Michelle?
Sure. Is there something up?
We're experiencing a bit of delay on your screen sharing. I was wondering if you could just stop it and then start it again.
Yeah. Okay. Stop.
I've been trying to find any other way to do it because I didn't want to interrupt you.
No, it's okay. How long has it been? Okay.
For a while.
For a while. Yeah. I've seen the light flickering a little bit, but okay. You there? I'm going to go forward. I'm going to go back. Did that show up?
Yep, that's much better.
Okay, cool. Sorry about that.
Nope, it's okay. It's the internet.
It's the internet. Oh, wait, I should have checked what time it was. I don't have my usual timer. Okay, I'm okay on time. I usually have like the presenter display with the timer and everything. Okay, so I'm going to get back into it. There's not that much left, so there's plenty of time for questions at the end once I stop looking at my slides, which are lovely, but they're just my slides. So error codes, status codes. Right, I was ranting about status codes. There are several. So on non-web platforms, a lot of people end up using some sort of HTTP library that helps them do a lot of the really basic things that the platforms themselves don't provide. On iOS, there's AF networking, Alnofire. There's a library by Square that I forget the name of on Android, and a couple other ones for desktop and embedded applications versus web applications. And for example, AF networking, what it does is if it sees that you got a 401, it will automatically parse, treat that as an error, and it will surface a lovely error object that we can handle in our native code versus having to go through and, okay, let me parse the JSON, let me check for an error key. Okay, there's no error key. Is there something else I need to look for? No. That's a lot more work, and it's a lot more automatic when it can just get done once via the status code. So error status codes, please use them. Another really incredibly useful thing, especially when it comes down to user experience, is having some sort of human readable error message. It's one thing when it's like a development server and you just want to like see stack traces, but it's another thing when you're actually shipping an application and oh, it's a siren. I don't know if you can hear it. It's noon in San Francisco, so we have a siren on Tuesdays. So error messages are so incredibly useful because usually a user has just done something. A user tried to increase the quantity of the item in their cart, and it turns out that the amount in their cart is the only amount available. That is a really important error that the user needs to know about. You know, if you're just building services that talk to other services, slightly less important. But a lot of us are dealing with APIs that end up surfacing content to users, and they're the ones that are doing the things that are going to cause the problems. So it's a lot easier to have that on the server because there's going to be more errors that happen over time. There's going to be more situations that happen, and relying on a client to have this like giant list of errors that could happen and then like one little fallback that's like, oops, something went wrong. Like people aren't going to like seeing, oops, something went wrong all the time. So human readable error messages are amazing. Just stick them in there, stick them in the JSON. Your client and consumers, like API consumers, will love you for it. So what are some not so great things to do? Really, really generic error messages don't help anyone. I mean, we all know this when we're debugging, that you want to make sure that you give enough information so that, you know, whoever did the error, no one knows what went wrong and has some idea of how to correct it. This is the same within, like, you know, API level. If I'm sending a string instead of a number because JSON, I need to know that. If there's the incorrect date format, I need to know that. Another pet peeve is that anytime, so this happens a lot, especially with JavaScript-based applications. So you have an API that will return a 200 all the time, everything's great, but then you parse the error in the response body. It is a more complicated code path for the people writing, the, you know, making the requests and processing the response. And it just takes a lot longer, and you know, it's just not as elegant. And you have like a bunch of if statements, and they're like, okay, so if we got this, we do that. If we get this, we do that. And it just makes for like really, really big chunks of code where you're just checking for like different keys and things, and it's just really messy. But that's not the worst that we've seen. I've had APIs that return HTML pages on error. And this isn't just when you get into the 500s, although a lot of servers automatically will just send an HTML page over the wire when there's a 500 or anything in the 500s, which is, you know, that's fine. The app will fall over. But, you know, I've seen things where it'll be like a 4.0, like a bad request, a 406, I believe. And it'll still return you an HTML page that says what was wrong, or even worse, it will do something like this, that, you know, if it doesn't exist, it has a 404 page that is actually a 200 because it was like a redirect kind of situation almost, and then it's HTML and it's actually a 404, but you got a 200 because everything's okay. So yeah, don't do it. Because what this really does is it just, I hope the GIF comes across in the video because it's hilarious. And these slides will be up, but the GIFs don't work in PDFs, unfortunately. But what this really does is it makes you think that you did this fantastic, amazing thing, but then somewhere, you know, behind you where you're not looking, things are going terribly, terribly wrong. And we like being explicit as developers. We don't like having to be clever and think about all of these things. Caching. Caching is super incredibly important, and I wish more people did talks about how to cache your APIs, because every time I start a new project, and I've started a lot of new projects, one of the first things I ask is, are you caching my responses? Because it makes such a huge difference for the end user experience. So the good things about caching are using one of the standards. Now, there are many standards out there that one can choose to figure out caching. Obviously, implementation is different. I'm talking about how to talk about caching between your API server and then the API consumer. Cache control headers. These are wonderful, amazing things because they are a standard, and therefore anyone who's implementing HTTP libraries usually has a way of caching things automatically for you. So if you just set a cache control header to like a day, for example, it will know that this information is not updated very frequently, and therefore will save everyone a lot of pain, although it makes debugging a little bit harder sometimes. So cache control, amazing, wonderful, use it. If modified since, you send a date or an etag, which I'll cover in a second. And then the server returns an empty response if nothing is new. The important part about that is, I write apps for phones, and people are on their phones all over the place, sometimes in the middle of nowhere in Montana with like 1 bar of edge. And so, sending an if modified since to check if there's new data is a lot faster than, sending a request, getting the full request JSON back, parsing the JSON to see if there's anything new, and then showing the response to the user. It makes everyone happier when you don't have to send the same data back over the wire again and again and again. And then etags. I know this is not the easiest thing to set up on the back end, just because you then need to kind of reproduce situations at certain places in time. But etags are fantastic because you don't have to worry about date formatting or anything. It's just a hash, and you say, hey, I have this hash. Has anything changed since this hash was the current hash? Like, is this the current hash? And it just returns you either an empty response, which is fantastic. I love empty responses. Or it returns you new data, and it only returns you the newer data, which also happens with if modified since, which is amazing and wonderful and makes my life so much easier and makes any consumer's life easier because you don't have to go through and check to see where the overlap is between the new data and the old data, which, let me tell you, I've written the code a lot. It's not trivial. So what's not great about caching, which is what I just said, which is manually processing data. So you're making a Twitter client and you need to get new tweets, but you can only get, like, the API you have to get tweets only returns you like the top 50 tweets in your timeline, like the newest 50 tweets. It doesn't ever tell you like which 50 those are in relation to the tweets that you already have. So if the current top tweet you have is not in that 50, you have to call another 50 and another 50 to figure out where your last seen tweet is, because that's not anywhere to be found. Or, it just keeps returning you the same data set over and over again because you're following like 2 people. And it's just a lot of work, and it's error prone, and it takes a long time to manually go through and double check that, the server said that the top tweets and what I have and what is on the server is the same, but is that really true? Because people have to delete tweets, and there's all these other things that have to happen. Versus just getting a payload that says this is new or these things changed, makes life a lot easier to actually use the data versus just kind of spitting out the same thing over and over again. And lastly, caching, ugly caching, is when you don't care. And you just send, cache control, no cache, no if modified since, no tags, no nothing. And it's just the same stuff over and over again. Not only is that costing the end users more because it's more time to get their data and for the consumers to process the data and to show the data, but it's also costing you more as someone who pays for servers, because if you are sending over, if you were like versioning photos, for instance, I mean, this would be huge if you were doing something like Instagram and where you could, or something like where you could edit photos. And you don't want to be sending over a giant thing every single time. You want to minimize the amount of data that you're sending because you pay for bandwidth and you pay for the server time. And wouldn't you rather just have the server do a quick lookup on like a hash or a date and say nothing's changed and move on, rather than have to go query the database and then maybe multiple queries to the database, build a JSON response, send it over the wire, which again you have to pay for because bandwidth, and then the consumers have to do all that stuff. So caching helps everyone. And just one quick side note about CDNs, because they can be really, really, really fantastic, and they help a lot with this, especially when you're building something at the scale that like Reddit did, for example. They switched from Akamai to Cloudflare a few months ago, and you have to be careful with CDN configuration, especially around authentication, because there was a rule in that it somehow decided to cache the OAuth login API we were using. So all of a sudden, everyone in the office was getting 403s because it was being cached. So caching is really, really fantastic, but you have to be really particular about what you cache and what you don't. Because accidentally caching an error for a resource that's accessed by a lot of different consumers is going to look like some sort of weird cascading failure when it's really just like your CDN rules are way too strict. So in summary, really good APIs are consistent. And that is one of the design goals that I always have when I'm talking with engineers about building these things. Consistent in how they describe data, how you get data, and how you check for new data, because it's just easier for everyone to deal with. APIs either follow well-established conventions so that people can look them up when there's a question, especially if this is like a public API, and there's going to be people using it who may not who aren't expert programmers, so they need to be able to look up what is a post, and be able to find those kinds of things. But conventions are also established internally within the API. So if there's multiple different things that page, if the API pages in the same way everywhere, that is a lot easier than saying, okay, well, if I'm getting a list of tweets, it pages like that, but if I'm getting a list of DMs, it pages like that. No one wants to write code to handle that kind of stuff. APIs really should establish their own conventions and then be consistent in how they implement them. And then, obviously, we all like really simple APIs. Leave the being clever to code that no one else is ever going to have to touch. But as soon as you're dealing with a significant amount of people elsewhere, not near you, having to use this thing, the simpler the solution, the better. So that's all I got. And I'm going to switch off screen sharing so that I can actually see the screen. And let me switch back over to Chrome. Okay.
All right, well, we'll go into Q&A mode. If anybody wants to actually vocally ask a question, you can go ahead and hit the Ask a Question button. It should be right over underneath the video where you see Michelle. And otherwise, we'll read questions out of the chat. Doug asked, what do most APIs do or don't do that they should besides live documentation?
Let's see. Most of them, the ones that I've used that are internal, not public, don't do any of the caching stuff, which is really annoying. So I'd say the number one thing to look into to make consumers happy would be some level of caching. How do you deal with versioning and deprecating APIs? That is a section I've been working on, but did not quite figure out how to fit in for today. Versioning is just like with the URL section, so you want something very explicit. I'm personally not a fan of the whole headers and like versions and headers thing, just because a lot of the time I'm going in and out of the browser every day. So especially when I'm just like creating a screen to, display a list of items, which is like the most common thing that you do in mobile applications is display a list of items. I usually actually just have the JSON up in the browser with me. So being able to have a URL that I can just get to, sometimes behind VPN or whatnot, is incredibly useful. So explicit versions so V1 API something like that, or API V1, however you really want to, set up your resources are great. And then deprecation. So to me, versions are for two things. They're for URLs and they're for payloads. So if a URL structure changes, it needs a new version, or if a payload, either a post put or the format of the get changes, that's when it needs to changes. That's what needs to change. If there's some weird thing happening on the back end, like you change databases or there's something that happened, but you can still send the same data for the same URL, then this is going to sound weird, but you don't really need to version in that case, because a version to me as a consumer only matters when I have to change my current implementation. And if outwardly nothing changes, then you don't need to version. How has your experience been with APIs using hypermedia approaches like HAL or JSON API? Do you see a lot of these formats? They're not really popular with the mobile crowd, mostly because we don't have support from our native platform. So there's no Google release library or Apple release library to do either of those. And we also have the problem where data flow and the way that apps are built is not very conducive to that. Android's a little bit better because you can launch different intents, but in iOS apps, especially iOS apps, because everything is very much more isolated, it's usually, we have to hard code URLs and endpoints everywhere just because there's no other real good way to do it. Because what happens if the network goes down and you can't get the URL list, but then you can make requests and it's kind of weird. So there's not a ton of pickup on that in the mobile world. So I had not had a lot of experience with them. Have you found that Ruby and Rails provide a good foundation for creating APIs? Yes, I'm a big fan. There's a Rails JSON, Rails API. It's called Rails API that I've used for little prototype apps a bunch of times. That it doesn't even have like any of the HTML stuff of Rails. It's literally just you have controllers and they expose JSON, and it has been amazing to work with for the few little things that I do on the side because it's so it's just duh. The problem that you get with Rails is when you start having to break the controller to model tie-in. So obviously you can just create controllers and they can do different things. But it just starts getting complicated when you have like a feed controller and then there's like this other controller and they're all accessing multiple models, and then you kind of have to worry about, really where should this thing live? So Rails is great. Just be careful that you don't have massive controllers that do too much. And I also am not a big fan of like having one API controller. I've seen that in a couple of Rails projects. And Reddit actually had that. They have an API file that has literally every API that is publicly available is in that one file. It's like 5,000 lines of code. I suggest you don't do that. Is there a perfect API out there that can be used an example of how to do it right? And then there's a link to Circle CI. I haven't looked at Circle CI's API. I have. There are a lot of them that are trying. Since I spent the last year with Reddit, I actually, as much as slow as that API is sometimes, it's probably one of the most consistent APIs that I've ever seen. In that they actually have names for the different kinds of payloads that you get. So each API will return, each call will return one kind of payload, and that's labeled. So like, it was really easy to go through and be like, is this a listing? Great, I know how to parse a listing. But I'm sure there are a ton of APIs out there that do it good. GitHub has a pretty good API. I don't like how they do paging though, but they do if modified since, I believe. So they do a lot of the caching header stuff. I haven't taken a look at Circle CI, so I have been using on that. And
Well, I don't see any other questions coming in. Thank you for coming, Michele.
thanks for having me. And I'm going to now stop. Well, oh, how do you like? There's one more question. How do you like to do paging?
Good one.
Yeah, that's a tough question because it depends on the kind of data that you have. So for something like Twitter, for example, where you're usually getting something sorted by an absolute value, in this case, time, then you can do paging in any number of ways. But I like doing it with an ID. So instead of just being like, give me 20 results starting at number 10, because once you get to a certain scale, item number 10 is going to be changing a lot. So it's very likely that, you'll need to, you'll get duplicates in that second page. So I like doing paging based on ID. So I have ID 36927. Give me the next 20 results. And that's kind of the sweet spot that I've found between, being really, really super incredibly explicit and still being able to handle the fact that data is going to be changing over time. Did you ever have the use case where you had to up and download bulk data in one request? Upload, yes. Download usually were separate, but the apps that I've built and the systems that I've worked with, usually it's a big upload or a big download. And unfortunately, when you get into those situations, there's not much you can do just because you're then just relying on the packets getting there. There are ways to efficiently upload on the client side, especially in mobile, that don't suck. They're not the best ways to do it. But I would definitely say avoid those at all costs, just because you have two very likely to fail situations that you're then stringing together. So if for some reason the upload fails, then you have a problem. But if the upload succeeds and then the download fails, that's, how do you tell the person who uploaded it that the upload actually worked, but then it wasn't able to properly send back down the giant thing? So that's probably one of the few situations in which you probably want to make two calls. So you'd want to do, like if it was like image processing, for example, and you want to do a big image processing thing that needs a server, what you'd probably do is upload the image to the server. Server says, okay, I got your image. And then you either poll or do a socket or something to check for when the download can start. Because, yeah, definitely don't chain those together, especially when you're dealing with cell networks, because packets will get dropped and there are some networks that just don't do well with large buckets of packets. What is an alternative? Chunking things up, obviously, is always the best choice if you can. Stuff like images is kind of hard to do that. And obviously, TCP takes care of a lot of that under the hood and sending out different, it chunks packets up and sends them over the wire. But in that situation, yeah, split it up and then have some way of restarting. Definitely have ways of restarting, because that is really incredibly important if you're doing big uploads and downloads. I know iOS has built-in support for downloads. Actually, iOS has built-in support for upload and download stuff that does that, but I don't think Android does, and I don't know if any of the web frameworks out there offer something like that. So split them up and then figure out, do you really need these things to be this gigantic, is what I'd suggest.
All right. Well, looks like you have exhausted all of the questions. So thank you again, Michelle.
Thanks for having me.
We'll get the talk up tonight, and you can go back and rewatch and feel smarter.
Hopefully the GIFs work. I couldn't tell if the GIFs worked.
They kind of worked. They were a little choppy for me, but maybe the
screen recording probably has them a lot better. Yeah.
Yeah.
Cool.
All right. Well, I'm going to go to presentation mode, and we're going to gear up for our next speaker, and that is Amos King, I believe. I looked before the talk, but not during the talk.
Well, he's the only one in presenter mode right now, so probably him. Oh no, never mind.
Nope, okay. Steve Klabnik.
Oh, gosh, I don't want to see that. I'm just going to see that. Okay.
All right.
Everyone.
Bye. We'll be back in a few minutes.